Far above the modern world, the moon shines out. Like an eye in the night sky, it has witnessed all the stages of our evolution and the transformations undergone by our planet. The moon has always marked the boundary between Earth and sky. And in our thirst for knowledge, we have always striven to get closer to it. Scientific advances have brought the distant object of desire within our grasp. In the 20th century, his wildest dream came true. Man walked on the moon. This is the story we are about to relate, a human adventure that takes us on an incredible journey through space and time. When men first observed the moon through a telescope, they saw a landscape of mountains and ravines that was oddly reminiscent of Earth. In the Renaissance, the moon, once so remote, suddenly seemed closer than ever before. It was a new continent to be annexed, a promise of voyages and discoveries to come. Science fiction was to relate the conquest of the moon, first in books, then in the earliest 20th century in films. Huge strides were made in science and technology. For the first time, people felt that the moon was within their reach. In 1902, for the first time, the moon featured as a character in a film. Georges Méliès' A Trip to the Moon made him world famous. It epitomized a new creative genre that combined lyricism with the latest scientific discoveries.
These difficult and laborious advances in science were accompanied by great cultural developments in man's imagination, fueled by research. Perhaps research was also stimulated by imagination. It was certainly reciprocal. Authors were already drawing on the work of scholars like Galileo, Copernicus and Newton, among others, to dream up men who would one day walk on the moon. The first space travel took place in the imagination. Its first destination was the moon.
For a very long time, people didn't want to stop believing in the possibility of some form of life on the moon. Of course, they actually had no idea at all. When they wrote about it, it was all the product of their imagination, which really says more about them as people than about anything else.
When they got to the moon, Méliès' scientists did what people had dreamed of doing ever since Galileo. They looked up and saw Earth in the sky, suspended on high as if by magic.
Not forgetting the numerous poets who, by turning to the moon, were seeking not only something opposite them, but also a reflection of their own existence. They sent out their hopes, fears and desires to the moon. They got back in return only what they had sent out.
Over the centuries, the moon has often represented an alternative, fantasy world, an ideal world, and they imagined, for example, that the people or beings who lived there would just look like human beings, while somehow being different too. Perhaps they'd only have a single limb, or part of one, only one eye, or only one ear, or they imagined that all the laws that applied there would be the other way round.
Observing the moon inspired many writers to try and imagine what its inhabitants were like. They called them the selenites. It was not until the 17th century that the celebrated astronomer Kepler gave a detailed account of this mysterious people. His was the first of many descriptions of the selenites. Each is different, but they all depict the inhabitants of the moon as peaceful beings who live in harmony with their surroundings. Like a reverse image of life on Earth, racked by wars and violent emotions. But these flights of fancy did not take mankind any nearer to the moon. The 19th century, when Jules Verne wrote his books, was a time of scientific discoveries, and his visionary works anticipated the advance of science.
Of course, when it comes to the moon, Jules Verne is a figure of special importance. At the time, he was living in Paris, right where so many scientists were working. He took in all their discoveries and weaved them together, using his gifted imagination to create these works. Their significance wasn't truly understood until much later.
Jules Verne's idea for getting to the moon, technically speaking, because that was the crux of the matter, was to use a cannon, but that raised the problem of getting back again. A whole host of ideas were put forward, but as it all took place in a fantasy world, how to get back didn't really matter.
Jules Verne's description of a journey to the moon in his novel From the Earth to the Moon is uncannily close to the truth. He was the first writer to anticipate astronomers' discoveries. Just a century later, Jules Verne's imaginings became a reality, and science put his seemingly far-fetched theories into practice. On the 20th of July 1969, at Cape Canaveral, reality outdid fiction. Television broadcasts of the Apollo 11 space mission marked the United States' victory over the Soviet Union after their decade-long race for the moon. Scientists' and philosophers' lyrical imaginings seem to have been replaced by a vision dominated by realpolitik. The moon had become a piece to be captured in the game of the Cold War.
Remember Kennedy's first speech? I think this nation should commit itself to achieving the goal of landing a man on the moon and bringing him safely to Earth. Highly impressive. That was a political aspect. But it was also important for the future of space exploration.
Neil Armstrong's, Buzz Aldrin's, and Michael Collins's journey to the moon was the first chapter in the great 20th century adventure of space conquest. It was primarily an American adventure.
good marks, over.
If man hadn't dreamt so intensely about the moon, if he hadn't drawn quarters of the moon on the caves at Lascaux, he would never have set foot on the moon, the greatest of sacrileges. But transgressing is part of being human.
Okay, all flight controllers, go for landing. Retro, go, right.
Flying to the moon was no longer an unattainable objective.
Surgeon, go. Go for landing, over.
It took the crew of Apollo 4 days to make the 384,000-kilometer journey.
4 forward, drift into the right a little. 30 seconds. Forward drift. Contact light. The Eagle has landed. Okay, I just checked step off the limb. That's one small step for man, one giant leap for mankind.
We all know Neil Armstrong's words, one small step for man, one giant leap for mankind. And just after him, Buzz Aldrin's magnificent desolation. It is desolate. There's no life, no clouds, no volcanic or climatic activity, no vegetation. And yet, it's magnificent all the same. So, respect.
Roger, the EVA is progressing beautifully. They're setting up the flag now.
La marche du premier homme.
Man's first step on the moon during the Apollo 11 mission was very probably a turning point, a culmination, the ultimate point in space conquest today. It's an unparalleled achievement.
The Apollo missions came to an end in 1972. In the course of the program, 12 astronauts had set foot on the moon. The Americans had secured political victory, but it was just the beginning of the scientific adventure. The US and Soviet missions had brought back soil samples from the moon. They turned out to be an absolute goldmine. Of all the mission's scientific discoveries, analysis of the lunar soil samples had the most far-reaching implications.
These samples went on to have a rather extraordinary story, because most of the major laboratories asked to use them so they could analyze them. A few samples were exhibited at major museums. You still see people today, including me, crowding around the display cases containing a sample of the moon.
They revealed an astonishing connection between the Earth and the Moon. They have an almost identical composition.
In terms of science of the Moon, in fact, it's studying the geology, the geochemistry of the Moon, to learn questions actually not only about the Moon itself, but about everything, about our own Earth, about the beginning of the solar system. On the Moon, for instance, first key question is how was the Moon formed?
Analysis of the Moon's surface has enabled scientists to work out how the solar system was formed. When the Sun was born, 4.5 billion years ago, a ring of debris and gas formed around it.
All of that material is moving around, and those little grains are starting to bump into each other and actually aggregate. So there is continual aggregation of bodies getting bigger and bigger over here, another one's getting bigger and bigger over here. Some object gets big enough that it has a lot of gravity, and that begins to pull in the other grains, so that begins to grow very fast. And what the computer models are showing in modern times is that there were planets growing in that way and emerging from all these smaller objects.
This is how the 8 planets in our solar system, Mercury, Venus, Mars, Saturn, Jupiter, Uranus, Neptune, and the Earth came into being. Analysis of the Moon rocks suggests that early on in the existence of the solar system, it contained other planets than the ones we know today. The Moon may have been created by a collision between the Earth and one of these stray planets.
It's a giant impact scenario, which is currently the favored one. And according to this, the proto-Earth was impacted by a large body the size of Mars called Theia. However, it would have been a slow enough impact so that a lot of material would be melted and there would be some debris.
It's interesting to realize that if you were standing out in space, floating out in space, watching this, how slow the whole thing would be. It takes minutes and hours for these objects to move close together. So it's very slowly coming together, and it first makes contact. And there's enormous light because the material at the point of contact where the two objects hit becomes incandescent. What flies off is the rocky material where on the surface of the two bodies where they hit each other. So now you have rocky material, which is, much of it is Earth material, and some of it is the impactor material, and that's the material the Moon is made out of.
This scenario was a bit confirmed after we got the first samples from Apollo and from the Lunar mission, the Soviet Lunar mission, because they saw the very close proximity between the composition of the sample and the composition of the Earth mantle.
Since the formation of the solar system, the fates of the Earth and the Moon have been inextricably linked. The Moon's surface contains a record of the Earth's history.
The Earth is geologically very active, and so when we study geology here, we're learning about the last half of the Earth-Moon's history, the Earth-Moon system history. But the Moon does not have the active geology, and so when you go to the Moon, you're really seeing more of the first half of the history of our system, of the Earth and the Moon.
When the Moon was first formed, it was subjected to a violent hail of meteorites that left its face scarred. Since then, its face has remained unchanged. The Moon looked the same to early humans as it does to us.
One of the very interesting discoveries from the very first Apollo missions was that the light-colored parts of the Moon, if you think of the dark spots in the Moon, people say the man in the Moon, or some ethnic groups see a rabbit in the Moon. Those are volcanic lava, but the bright part around it is the old crust of the Moon. That's where all the craters are. So that was a signal that the Moon had been molten in the surface layers, and that came to be called a magma ocean, magma being molten lava. That fits with the idea of very rapid formation of the Moon. We talk about forming the Moon in a few thousand years. If you go to Hawaii or any volcanic region, some volcanic park where you can see molten lava, when it comes out, it's glowing red hot, but if it's flowing on the surface, within minutes it forms a thin crust that is solidified. So it changes from this red glow to just a dark gray surface.
Held together by gravitational forces, the Earth and the Moon clasp each other close, like a pair of dancers waltzing around the sun. Once they had formed, the two celestial bodies cooled. Gradually, the Earth acquired its blue color, which results from the oceans and the precious layer of atmosphere covering its surface. On the surface of the Earth, the elements raged. The Moon's gravitational pull created the ebb and flow of tides.
So by understanding the principles of gravity, we can also understand much more easily why there are tides. So what happens is if we focus on the Earth and Moon system, where the Moon is, the gravity of the Moon will pull on the ocean, which will give rise to a high tide in the direction of the Moon and a low tide in the two directions perpendicular to this. And as the Earth rotates, of course, we will have a wave, so we will see the tide going up and down.
The Moon set the pace for the newborn world. It acted as midwife for the new life that gradually evolved in the depths of the oceans. Through the ebb and flow of their tides, these great masses of water gradually slowed the Earth's rotation.
Originally, the Earth spun on its own axis much quicker than it does now. It took about 20 hours to rotate on itself 400 million years ago. Today, it takes 24 hours, so it has slowed down because of the tides, and this slowing down is continuing.
For us, this slowing down is imperceptible, but it is definitely happening. The Moon was originally much closer to the Earth than it is today. For our earliest ancestors, 400,000 years ago, the Moon was about 15 kilometers closer than it is today. On the scale of the cosmos, the difference is tiny, but the Moon must have been very impressive to the human beings of the time. It would have been much bigger in relation to the sky. The Earth and the Moon may be inseparable, but life could not have developed without the Sun, around which the entire dance revolves. Apart from the gravitational pull it exerts on the Earth's oceans, the Moon acts like a pendulum in a giant clock.
The seasons on Earth are not caused by the variations in the Earth-Sun distance. They are solely a result of the angle of the Earth's axis of rotation, being tilted at roughly an angle of 23.5 degrees, which produces a variation in the Sun's height throughout the year. When the Sun is high up in the sky, it's hot. When it's low, it's cold. And so this varying height in relation to the months is due to the angle of the axis of rotation. This angle is not stable. The Moon plays the role of stabilizer on a scale of several tens of millions of years on this axis of rotation, which maintains the seasons within certain limits.
It keeps the Earth turning on its axis, thereby ensuring that the seasons follow a regular pattern. It's the combined action of the Sun and the Moon that has given rise to the miracle of life on the Earth.
The Earth as a geological and mathematical body is not fragile. I think it's rather ego-anthropocentric to say the Earth is fragile. It reduces the Earth to life. It's life itself that's fragile. One of the most striking images from my first flight was when I looked at the horizon. I wanted to see what the atmosphere looked like from space, from its profile. On the scale of planet Earth, the atmosphere is as thin as cigarette paper. If you took a pencil and drew a circle with a diameter of 10 centimeters on a piece of white paper, a circle about this big, 99% of the atmosphere would be contained in the width of the pencil line. Our human, vegetal, and animal life depends on this thin stream of oxygen, which is extremely thin on the scale of the planet, and which appears so fragile seen from space.
Apart from scientific discoveries, the moon missions offered us a revelation. They made us look at our blue planet in a totally new way.
The environmental movement was born at the same time as Apollo missions, with the view of Earth rising on the lunar horizon. The moon has given us something extraordinary, because man was able to go there, to approach the moon. It became a vantage point from which he could look back at the Earth. And that's a huge milestone in the history of mankind.
This conquest of space has given us an ecological awareness of our planet. This ecological awareness is all the more significant for each one of us, as it hasn't just been seen by satellites, probes, and satellite sensors, but astronauts have seen it with their own eyes and brought that sight back and shared it.
In 1975, at the height of the Cold War, the crews of two spaceships, one American and the other Soviet, joined hands in space. The amazing Apollo-Soyuz meeting ushered in a new chapter in the conquest of space.
We can consider the moon as being part of an interesting movement that is now nearly 50 years old. The race to the moon, the space race. This has not just been a race between rivals, it has also been an arena for learning and cooperation.
In the late 20th century, the moon became a place where countries could fraternize and work together. The Near-Earth International Space Station, ISS, symbolizes altered attitudes.
The general public think that astronauts who go into space travel far, far away. But we're actually only 400 or 500 kilometers from the Earth. The International Space Station is 400 kilometers from the Earth.
The ISS has been manned continuously for 14 years, a record in the history of space missions, with crews taking over from each other every 6 months.
When we fly over Paris, for example, the astronauts are closer to the Parisians than the Parisians are to the people of Toulouse. Amusingly, on my first space flight, I was pedaling on board in the cockpit to get some exercise. The shuttle was angled on its back and crossways, moving along like this. And when I looked out of the top window that was facing the Earth, I could see the Earth moving past in the same direction as I was pedaling. I felt like I was pedaling across the Earth, and it only took me 2 minutes to cross France.
Taking time out in the space station To look out of the window is really a magical moment. Watching the Earth go past. Orbiting the Earth takes 90 minutes. I say 90 minutes because we orbit the Earth 16 times a day. Orbiting the Earth means seeing it in daylight for 45 minutes, then seeing it during night for 45 minutes. And it also means seeing 16 sunrises on the Earth's horizon and 16 moonrises on the Earth's horizon.
With the ISS, the Moon leads us to new discoveries. The station is a fully fledged laboratory where many unique experiments have been conducted to test what it would be like to spend longer periods in space. Here, the astronauts are testing scientific theories in a gravityless environment. Their findings will feed into research in all sorts of areas.
Of course, as professional astronauts, we undergo extensive training to become acquainted with the station's systems, ensuring their autonomy and safety so that the crew members can intervene on the station's various systems. But my main objective was to carry out a scientific program. A scientific program in a very specific laboratory. A lab in orbit, in microgravity, which enables us to ask fundamental questions about how a system behaves when it's not subjected to gravity. Whether it's a living system, a fluid system, a plasma-forming system, or an alloy-forming system. So we're looking at physiology, biology, the physics of fluids, the physics of solids, and multiple fields of investigation.
On board the International Space Station, we carry out astrobiological experiments with extraordinary extremophile animals called tardigrades. They're nicknamed water bears because seen through a microscope they look like little bears. They are 1-2 millimeters long, and they can survive in extreme environments, in very strong variations of temperature from minus 150 to more than 200 degrees Celsius, in a vacuum, in ultraviolet rays that would be fatal to humans. They can withstand exposure to cosmic rays that are also very harmful to humans and which destroy DNA very quickly. If you expose these small animals to the vacuum directly in space with no protection, they know what physiological configuration to adopt, how to slow down their metabolism, how to enter a latent state in order to survive, and wait until they encounter humidity or a little pressure or a more suitable temperature to be able to continue developing, reproducing, and carry on living. We discovered life in extreme environments rather recently on Earth. We carried out experiments on it directly in a space environment without protection, and it works. Which gives us good hope for the future of Earth life and its ability to adapt to the extreme environment of a space vacuum.
This human scientific and technological adventure has provided the most wonderful opportunity for fulfillment and for experiencing all these facets. It has provided an opportunity for self-questioning, for learning, and for continuing to learn your whole life long. I think that's what's so fascinating about our careers, being able to discover and explore your whole life long. And we use this exploration to explore ourselves and to evolve.
Human beings have always aspired to conquer new places and to outdo themselves, to push back boundaries. Many of those aspirations have centered on the Moon. The Moon has always been closely associated with our thirst for knowledge and our desire to explore new worlds. Have we finally outgrown the Moon? It almost seems as if we have forgotten it.
Did we abandon the Moon after the Apollo missions? Yes and no. In terms of the Moon as a focal point of interest for the media, the general public and politics, I'd say that it was abandoned, yes, until the Chinese finally started mentioning their lunar ambitions in the early 2000s.
Away from the big space agencies and their joint program, the emerging superpower of China is rekindling interest in the moon. As the 21st century dawns, China's economic growth is enabling it to throw itself enthusiastically into the task of conquering space. Its first goal is the moon. This technical feat provides an opportunity to revisit one of China's oldest traditional myths, the story of the Taoist moon goddess, Chang'e. At the first full moon in autumn, the Chinese celebrate the Moon Festival, a symbol of harmony and family unity. During the Moon Festival, people give each other mooncakes, bearing Chang'e's likeness as tokens of prosperity and happiness. In homage to the moon goddess, China's moon missions are called Chang'e, showing that China is determined to get itself noticed in the space fraternity. Following the success of Chang'e 1 and Chang'e 2 in December 2013, the Chinese government launched a third mission, a robot scheduled to conduct lunar soil analysis and bring back samples in around 2017. The robot is called Yutu, in allusion to the jade rabbit, who is the goddess Chang'e's faithful companion in Chinese mythology.
What's surprising with Jade Rabbit, but in fact it's just a matter of the way the information about it was processed, was this personification and the use of new resources in the form of a small blog, the blog of Jade Rabbit. Apparently it's not a Chinese space agency initiative, but an initiative by enthusiasts, by space fans.
Over 600,000 people have registered on the blog. They log on daily to follow the Jade Rabbit's mission. People seem to be just as fascinated with the moon as ever. The only thing that has changed is the characters in the story. After the spectacular television footage of the Apollo missions, the internet age allows us to make a direct connection with the moon via a small robot.
For China, their supreme ambition is to be recognized on a par with the ancient powers and with the major space powers. It's not so much a question of doing 60 years later what the US has already done, but in this 60 years later, there's the fact of doing the same thing, which is important. So their aim is to say that if there are major expeditions to Mars, or major scientific expeditions of planetary exploration, they will be partners to them in their own right. And so, in a way, they're wiping out their delay, which was an enormous delay in the area of technology, which lasted throughout the 19th century, of course, but also the 20th century.
It's over 40 years since a human being last walked on the moon. China wants to be the first to go back there with a manned spacecraft. Its aspirations are rekindling interest among the other space agencies. They now see the moon as a stepping stone to Mars.
Going to the moon necessarily involves mastering technology, mastering the construction of a vast program, and pooling resources and making sure they work well together. So this experience is rather unique and to an extent goes beyond the conquest and discovery of the moon. That's perhaps one of the greatest things about space, the idea that we can work together there, proving that beyond earthly divisions, when we're in space, we express great solidarity.
The moon has helped mankind to find ways to get on with each other. It has taught us much. But it has by no means yielded up all its secrets. We are still intrigued by its hidden side. It's probably on the dark side that we will get a new perspective on the universe.
This is the only place in the solar system that doesn't see the Earth. For this reason, it's not contaminated by all the radio background that emits the Earth. The Earth is a very noisy emitter of radio waves. Your TVs make a lot of noise. And on the far side of the moon, this is the quietest place in the solar system. So if you want to study the universe in those frequencies, radio frequencies, also if you want to listen to extraterrestrial signals, or if you want to study the deep universe, you could put radio telescope on the far side.
Since Apollo, we have constantly sent probes, robots, and satellites to the moon or the area of space that surrounds it. The goal has always been to build habitable lunar bases. Whatever infrastructures are built on the moon, future missions will depend heavily on progress in robotics. Highly sophisticated robots will prepare the terrain and conduct soil analysis before the next astronauts land on the moon.
So I see that within a 10 years time frame, we will have a new decade of robotic landers and emplaced by different countries or collaboration of countries that we try to define in a way that they could share some assets as well and coordinate and work like a robotic village as a preparation for the following step, which will be the emplacement of larger infrastructure that would lead to the sustainable lunar base.
The latest technological advances are taking us closer to a future in which astronauts will be able to live on the moon in bases equipped for long periods. With the help of robots, man is about to embark on a new and decisive stage in the conquest of space.
The moon's an ideal terrain for experimentation because it's not very far away. That's the main advantage of the moon. It's a place for learning and gaining know-how, which is of prime importance.
One of the practical problems faced by astronauts during long periods in space is their vulnerability to cosmic rays. So they would need accommodation that could protect them from radiation. We now know that 3D printers will be able to build radiation shelters on the surface of the moon. The multifaceted moon turns out to be a springboard for other discoveries. Just as it always has, the moon is accompanying the human race on the next phase of its never-ending journey.
It also has potential for the extraction of resources that can't be accessed elsewhere. I'm thinking in particular of helium-3.
As a result of our galloping energy consumption and our ever-increasing needs, the Earth's environment is becoming increasingly polluted. Helium-3 is a fuel that could be used in a new generation of nuclear power stations. There's enough of it beneath the surface of the Moon to meet our energy needs for hundreds of years. Its commercial potential may herald fresh conquests of the Moon in the near future.
So, is there a risk in exploiting resources of the Moon? And how can we protect this environment? First, there are regulations. There is a so-called out-of-space treaty, which regulates all outer space activities, including the Moon and other planetary targets, which stipulates first that nobody on the Moon, no country, no individual on the Moon, and there is a charter how to respect the environment there.
Now and in the future, whatever the lunar projects we're involved in, we are responsible for what we do there, and even for what some of us want to do there. I think that is a fine continuation of this story, in keeping with the whole history of the Moon. We must not forget everything the Moon has brought us, in terms of symbolism, religion, science, and in terms of calendars, and so on. The Moon is the first body concerned by space law. It is up to us not just to declare it a common heritage of mankind, but to make sure it really is.
It's hard to imagine what the Earth would be like without the Moon. Life on Earth as we know it could not have come into existence without it. Apart from the resources it may provide, the Moon is an important symbol and a record of our evolution.
When you're in space, unlike what we're used to on Earth, in the middle of the day, the sky is jet black. In your field of vision, which is jet black, you see the Earth, which is rather huge as you're quite close to it, the Moon, when you're in a direction where you can perceive it, and the Sun. There's nothing else, just the Moon, the Sun, and the Earth. The Earth passes by very rapidly, 28,000 kilometers per hour. From time to time, you can see a silver reflection on its oceans. That's the Moon, the reflection of the Moon, seen from space. On Earth's rivers, seas, and oceans. It's the same color as the Moon seen from the ground, because it's a reflection that has penetrated the atmosphere. It's magnificent.
When you look out of the window on the Earth side, the planet side, you see the Earth. And that feeling makes you aware of how finite and fragile it is, and of what that means in terms of our responsibility to it. And then you look out the window on the cosmos side, the infinite side, the mysterious side, still to be explored forevermore, to advance the tiny amount of knowledge we have. You realize how deep a mystery it is, how little we know.
Throughout the history of mankind, the Moon has been an object of wonder and curiosity for human beings. We've continually learned from it. The Moon has enabled us to fulfill one of our wildest dreams. Setting foot on the Moon was the first step. Today, the Moon offers us a gateway to the universe. It inspires us to push ourselves still further and explore infinity.